VPC is the foundation of our AWS network because it provides an isolated environment where all cloud resources will be deployed. During this step, we configure the VPC with the required network setting so later the service can communicate securely. So we have successfully created a Potato VPC. Next, we're going to create our internet gateway named Potato Internet Gateway. The internet gateway was attached to our VPC to enable communication between resources inside the public subnet and the internet. Without this gateway, users outside AWS would not be able to access our web application. Next, we have to allocate a Elastic IP address. An Elastic IP address is a static public IP that remains unchanged even if an EC2 instance is retired. It provides a consistent public address for accessing AWS resource and is an important component of our network infrastructure. We can see that AWS has allocated the public IPv4 address successfully. Next, we have our subnet created. This subnet was configured according to the network design and provide one segment of our PPC. Each subnet has its own IP address range to avoid overlapping addresses. Using multiple subnet improves network organization and allows resources to be distributed across different availability zones for higher availability. This subnet is part of our private network where backend resources can be deployed securely without direct internet access. And together, the four subnet provided separate network segment for public facing service and internal application component. This design improves scalability, fault tolerance, and security. Next, we have to create our route table. First, we have to create our public route table. This public route table is associated with the public subnet and contains a default route pointing to the internet gateway. This configuration allows resources inside the public subnet to communicate with external network. Next, we have to create our private route table. This route table is associated with the private subnet and does not provide direct internet accesses. As a result, backend service such as private EC2 instance and RDS database remain protected from directed external access. To conclude, in phase 1, we have successfully completed the network infrastructure by creating the VPC, attaching the internet gateway, allocate the elastic IP, creating for subnet, and configured the public route table and the private route table. This network architecture established a secure and scalable environment for the remaining phases of the project. Thank you.
Now I will talk about phase 2, which is EC2. So first, I'll talk about how we deploy our web application on Amazon EC2 and prepare it for scaling. First, I create the baseline instance TRT EC2 in the public subnet 2. I selected the Amazon Linux AMI, chose a T2 micro instance and attached my key pair for secure SSH access. Next, I configure the web security group to allow SSH for administrators and HTTP for users. I also added a user data script to automatically install Apache and PHP, download the lab files, and start the web server. This ensured the instance was ready immediately after launch. Once the baseline server was running successfully, I created an Amazon machine image named TRTEC2-baseline. This AMI captures the configuration so we can replicate the same environment consistently. Using this baseline, I launched two identical EC2 instances, one in private subnet 1 and the other one is private subnet 2. These servers inherit the baseline setup but remain isolated from direct internet access, preparing them for load balancing in phase 3. So this will be the rest of the video on how I completed phase 2 EC2.
target group is named as TRT-TG, and the health checks are configured on the port 80 with the path slash. When shows healthy, the load balancer can distribute the traffic evenly. TRT-EMP inside the group named VPC. By placing into public subnet for high availability, the load balancer forwards the traffic to the target group, which contains our baseline EC2 instance. This template defines the AFI, instance type, security group, and user data script. Automatically install and start Apache. This ensures that any new EC2 instance launch will be ready to serve the traffic immediately.
Good evening, sir. My name is Muhammad Haris Haikal bin Irman, and my parts for in my group are responsible to handle the phase 4, which is the database creation. So let's go through what I have done in phase 4. So first we need to create the subnets. So in the subnet we attach the two subnets, two private subnets, private subnet 1 and private subnet 2. And we also attach our teams with VPC into these subnet groups. So let's continue to the database creation. We go to Aurora RDS, actually in the same page of the subnet groups, but just go look up a bit top, and this is there are the databases options here. Just click and we'll be directed here, and we can click create database, full configurations, and will be first show the options of the engines. So for the engine, stated by the instructions, we should choose MySQL. Okay, we will choose MySQL. The templates, there are nothing. And for the availability and durability, we will choose the multi-AZDB instance. And we're going down to the settings parts. Settings parts. So here we need to give a name to the instance identifier, and we give a name potato dash database, and the credentials nothing to do, just let it be. And we continue to, we're going for the a bit downs. Here is the instance configuration. So in the instance configurations, we must use the burstable, this one, burstable classes included T class, and choose the DBT2 micro. But for my cases, the DBT2 T2 micro are not available, so I just choose the DBT3 micro. And this is the storage. For the storage part, we should change this ones. Yeah, we should change this one to GP2 SSD. General purpose SSD GP2, and the allocated storage 20 is stated in instructions. And that's all for these parts. And I think so for the connectivity. For the connectivity, yeah, the VPC we should I choose my Teams VPC. Change to Potato VPC. Don't use the default one. And the subnet, of course, we use the TRT subnet, which we have created earlier. And then for the public access, Okay, this one for the public access, we don't want this database to be publicly access, so we just put no. And for the VPC security group firewall, don't use the existing one. You need to create a new one for databases. So we give it a name, DB security group. So that's it for the naming, and we continue to this one. Don't tick this one. There's nothing inside here. We can skip the text, the monitoring. Yeah, we need to uncheck this enable enhanced monitoring. We need to uncheck this one. Right. Okay. We need to uncheck this one. Yep. Uncheck that one. And there are something we need to do inside the additional configurations, which is we need to give in the name to this database. So we given a name potato dash databases, and I think that's all for everything we need to do inside this database configuration. We're just going up and down to confirm, double confirm before creating, and we can just create database. Okay, yep, database, creating database. Yep. So here it will took roughly 2 to 3 minutes, 2 to 3 minutes before the database to be created. And after be created, okay, take quite some times to be create. And here after 2 to 3 minutes, the status will be changed to modifying. So it will took at this part, it took a bit much more longer. It take 5 to 10 minutes, I think, to be available. So I just cut this parts, and straight away the database are available. So we will go through again the database, the detail of this database. So here, this is the database summary, the ID of the database, the status, the class, DBT2 micro, the engine, MySQL, and the regions. So yep, this is the master credential. This is the security group that we created and attached, and this is its replicate in another regions. So we go into the configuration tab. Yeah, inside the configuration tab, the DB instance ID, the DB, the database name, and also all the things here, the instance class, DBT3 micro, 2 CPU, 1 gig RAM, the username, the multi-AZ ECS, and the storage type, GP2 SSD, storage 20 GB, and yep, that's all for phase 4 of our groups. So that's all for my parts. Thank you.